Welcome everyone. Thank you for joining today's training session on respiratory protection. This training material has been prepared by Ahmad Jafar, AMCO HSE trainer. This training is crucial for ensuring our safety and health in environments where airborne hazards are present. We'll cover the importance of respiratory protection, different types of respirators, proper usage, and maintenance practices. By the end of this session, you'll have a solid understanding of how to protect yourself and others from respiratory hazards. Let's get started. Training outline. Introduction to human respiratory system. Introduction to health risks from hazardous substances. Assessment of health risks. Control measures. Emergency response and first aid. Training evaluation. Exam. Introduction to human respiratory system. Overview of the human respiratory system. The human respiratory system is responsible for oxygen intake and carbon dioxide expulsion. It consists of the nasal cavity, pharynx, larynx, trachea, bronchi, and lungs. The alveoli in the lungs facilitate gas exchange with the bloodstream. How we breathe. Breathing is a two-phase process: inspiration, air intake, and expiration, air expulsion. The diaphragm and intercostal muscles create pressure differences that drive airflow. Introduction to health risks from hazardous substances. Forms of chemical agents. Solid, a solid block of material, e.g., lead ingot, that cannot enter the body in its massive state. Liquid, free-flowing fluid, e.g., water at 20 degrees Celsius. Gas, expands to fill available space, e.g., carbon dioxide. Dust, tiny solid particles created by grinding or blasting, capable of becoming airborne, e.g., flour dust. Fibers, thread-like particles that can become airborne, e.g., asbestos. Fumes, small metallic particles formed during work with molten metal, creating an airborne cloud, e.g., welding fumes. Mist, small liquid droplets suspended in air, usually from spraying, e.g., paint mist. Vapor, gaseous form of a substance that is solid or liquid at normal temperature, e.g., acetone vapor. Work activities can lead to the contamination of air with harmful substances. This can occur during various processes, including crushing, transforming, staking, and handling oil, shale, and ash. Cutting materials like stone or wood. Using products that contain volatile solvents. Welding stainless steel. Additionally, workers may need to operate in environments where oxygen levels are or may become low, such as confined spaces like trenches, silos, or tanks. Forms of biological agents. Fungi includes molds, yeast, and mushrooms. Most are harmless, but some can cause diseases like athlete's foot and farmer's lung. Bacteria, single-celled organisms found in large numbers on and in the human body. Some are harmless or beneficial, e.g., gut bacteria, while others cause diseases, e.g., Legionnaire's disease. Viruses, tiny infectious organisms that reproduce by hijacking living cells. Many cause diseases, e.g., hepatitis B. Acute and chronic effects. Acute effects. Short-term effects that appear immediately or within minutes after exposure. Often caused by high levels of a substance over a short period. Example, high concentrations of chlorine gas cause immediate respiratory irritation. Effects usually disappear after exposure stops, but some substances, e.g., cyanide, can be fatal. Chronic effects. Long-term effects that can last months, years, or a lifetime. Result from lower levels of exposure over long periods. Example, repeated exposure to flour dust can cause lifelong respiratory sensitization. Effects are gradual, progressive, and often irreversible, sometimes appearing years later, e.g., asbestosis. Workplace-related respiratory illnesses. Occupational asthma, caused by inhaling fumes, gases, dust, or other substances at work. Chronic obstructive pulmonary disease, COPD, exacerbated by long-term exposure to harmful dust, chemicals, and fumes. Pneumoconiosis includes diseases like black lung, coal dust, and silicosis, silica dust. Asbestosis, chronic lung disease from inhaling asbestos fibers, common in construction and shipbuilding. Hypersensitivity pneumonitis, allergic reaction to inhaled organic dusts, such as moldy hay or bird droppings. Legionnaire's disease, severe pneumonia caused by Legionella bacteria in workplace water systems. Assessment of health risks. Routes of entry. Inhalation, breathing in hazardous substances in gas, vapor, mist, fume, or dust form through the nose and mouth into the lungs. Types of dust. Inhalable dust, particles of all sizes that can be inhaled into the nose and mouth, 100 m or more. Respirable dust, particles smaller than 7 microns that can travel deep into the lungs and enter the region of gas exchange. Defense mechanisms. Cellular defense, internal cells fight bacteria and toxins entering through blood, respiratory, and ingestion routes. Superficial defense, external protects against toxins entering through the skin and traps contaminants in the nose and throat using hairs and mucus. Respiratory defenses. Sneeze reflex, expels irritants from the nasal cavity. Nasal filtration, thick mucus lining traps large particles, only particles smaller than 10 microns pass through. Respiratory defenses. Mucociliary escalator, cilia move mucus and trapped particles out of the lungs, effective for particles larger than 7 microns. Macrophages/phagocytes, white blood cells ingest and destroy fine dust particles not captured by mucus. Inflammatory response, thickens and scars alveoli walls if particles can't be removed, potentially causing conditions like silicosis and asbestosis. While the respiratory system has several defense mechanisms, it also has limitations. Large quantities can swamp our defenses. Toxic, poisonous, or infectious particles can damage our lungs as well as other parts of the body. Sensation particles can trigger allergic reaction like asthma. Very small particles can bypass most of our defenses to reach the lungs. The body cannot filter out harmful gases. Occupational exposure limits, OELs. Definition: maximum concentrations of airborne substances that workers can be exposed to, averaged over a specific time period. Purpose: to prevent health risks from high concentrations of hazardous substances. Occupational exposure limits, OELs. Types of exposure limits. Short-term exposure limits, STELS control sudden, acute effects from short-term exposure, e.g., 15 minutes. Long-term exposure limits, LTELS control long-term, chronic effects from prolonged exposure, e.g., 8 hours. Control measures. Elimination. Eliminate processes, outsource operations requiring hazardous substances, e.g., paint spraying. Change work methods, use alternative methods to avoid hazardous substances, e.g., screwing instead of gluing. Substitution. Replace hazardous substances with less harmful alternatives, e.g., using water-based paints instead of solvent-based. Engineering controls. Process change. Application methods: apply solvents by brush instead of spraying to reduce airborne mist and vapor. Cleaning methods: vacuum instead of sweeping to keep dust levels down. Segregation. Segregation: store hazardous substances in designated areas away from other work processes. Ventilation systems. Local exhaust ventilation: LEV extracts contaminated air at the source and filters it before releasing clean air. Dilution ventilation dilutes contaminant concentration by changing air in the workplace, suitable for gases and vapors. Dilution ventilation dilutes contaminant concentration by changing air in the workplace, suitable for gases and vapors. Enclosures. Process enclosures enclose hazardous substances within machinery or storage tanks to prevent escape into the workplace. Isolation, use barriers or partitions to separate hazardous processes from workers. Automation. Automate processes to reduce human exposure to hazardous substances, e.g., automated mixing systems. Dust control. Dust collectors. Dust suppression systems. Vacuum systems. Regular housekeeping. Administrative controls. Reduce exposure times. Minimize the time workers are exposed to hazardous substances to reduce the dose received. Health surveillance. Medical clearance, importance of medical evaluations for workers who use respirators. Health monitoring, ongoing health monitoring and re-evaluation requirements. Training and education. Exposure monitoring. Respiratory protection equipment, RPE. What is RPE? Respiratory protective equipment, RPE, refers to devices designed to protect the wearer from inhaling hazardous substances in the air, such as dust, fumes, gases, and biological agents. RPE can either filter out contaminants or supply clean air from an independent source. Types of RPE. Filtering devices. Disposable respirators, single-use masks that filter out particles. Commonly used in environments with dust or non-toxic particles. Reusable respirators, masks with replaceable filters for particles, gases, and vapors. These are more cost-effective for long-term use. Powered air purifying respirators, PAPRs use a battery-powered blower to pass contaminated air through filters. Suitable for environments with higher levels of contaminants. Breathing apparatus. Supplied air respirators, SARS deliver clean air through a hose from a stationary source. Ideal for confined spaces or areas with limited oxygen. Self-contained breathing apparatus, SCBA, provides clean air from a compressed air cylinder. Used in highly hazardous environments, such as firefighting. When to use RPE. Insufficient engineering controls, when ventilation or other engineering controls cannot reduce airborne hazards to safe levels. Emergency situations, during spills, leaks, or other emergencies where exposure to hazardous substances is likely. Specific industries, in sectors like construction, healthcare, and chemical manufacturing where workers are regularly exposed to harmful substances. Selecting the right RPE. Risk assessment, identify the type and level of hazard present in the environment. What is an APF? The assigned protection factor, APF, is a number that shows how much protection a respiratory protective equipment, RPE, can provide. For example, if an RPE has an APF of 10, it means it can reduce the wearer's exposure to harmful substances by at least 10 times. So, if there is a harmful substance in the air, the wearer will only breathe in 1/10 of it. How to choose the right APF. Check safety data sheets, SDS. Look for advice on the required APF. COSHH assessments, check if there is advice on the required APF. Workplace exposure limit, WEL. Ensure the RPE protects the wearer to a level below the WEL. Calculating the required APF. If there is no advice on the required APF in the SDS or COSHH assessments, you can calculate it using the WEL and the amount of the substance in the air. Example calculation. Find the amount of substance in the air. Suppose the concentration of a harmful substance is 350 ppm, parts per million. Determine the WEL. Assume the WEL for the substance is 50 ppm. Calculate the required APF. Divide the concentration by the WEL. Required APF equals concentration equals 350 equals 7. In this example, you need an RPE with an APF above 7. In this case, an APF of 10 will be required. Choosing RPE for multiple hazards. If there are multiple hazards, calculate the APF for each and choose RPE based on the highest APF required. Disposable half-mask respirators, usage guidelines. Classification and protection factor. FFP1, protection factor of 4. FFP2, protection factor of 10. FFP3, protection factor of 20. Work rate, suitable for medium work rates across all classes. Continuous wear time, recommended for less than 1 hour. Effectiveness, effective against solid or liquid particles. Fit testing can be done qualitatively or quantitatively. Standards complies with BSEN 149. Important note: masks marked NR, not reusable, should be used for a single shift only. P1 and P2 filters are not recommended for fumes unless specified. Reusable half-mask respirators, particles filter, usage guidelines. Classification and protection factor. Half-mask plus P1 filter, protection factor of 4. Half-mask plus P2 filter, protection factor of 10. Half-mask plus P3 filter, protection factor of 20. Work rate, suitable for medium work rates across all classes. Continuous wear time, recommended for less than 1 hour. Effectiveness, effective against solid or liquid particles. Fit testing, required, can be done qualitatively or quantitatively. Standards, complies with BSEN 140 mask and BSEN 143 filter, BSEN 1827. Important note: P1 and P2 filters are not recommended for fumes unless specified. Always clean and store the mask properly, paying special attention to the valve. Reusable half-mask respirators with gas/vapor filters, usage guidelines. Classification and protection factor. Gas, protection factor of 10. FFP3, protection factor of 4. FFP2, protection factor of 4. Work rate, suitable for medium work rates across all classes. Continuous wear time, recommended for less than 1 hour. Fit testing, required, can be done qualitatively or quantitatively. Standards, complies with BSEN 140 and BSEN 14387, BSEN 405, BSEN 149. Important note: if used to protect against particles, the protection factor will be reduced to 4 unless a particle filter is incorporated. Full-face mask respirators with particle filters, usage guidelines. Classification and protection factor. P1, protection factor of 4. P2, protection factor of 10. P3, protection factor of 40. Work rate, suitable for medium work rates. Continuous wear time, recommended for less than or equal to 1 hour. Effectiveness, effective against solid particles only. Fit testing, required, can be done qualitatively or quantitatively. Standards, complies with BGEN 136 mask and BGEN 143 filter. Important note: always clean and store the mask properly, paying special attention to the valve. Badly presented and deformed exhaustion valves will be incapable of sealing. Full-face mask respirators with gas/vapor filters, usage guidelines. Classification and protection factor. Gas, protection factor of 20. Work rate, suitable for medium work rates across all classes. Continuous wear time, recommended for less than 1 hour. Effectiveness, effective against gas and vapor. Fit testing, required, can be done qualitatively or quantitatively. Standards, complies with BSEN 136 mask and BSEN 14387 filter. Important note: if used to protect against particles, the protection factor will be reduced to 4 if a P1 filter is incorporated, or to 10 if a P2 filter is incorporated. Powered respirators with masks, usage guidelines. Classification and protection factor. TM1, protection factor of 10. TM2, protection factor of 20. TM3, protection factor of 40. Work rate, suitable for medium to heavy tasks. Continuous wear time, recommended for more than 1 hour. Effectiveness, effective against solid or liquid particles, gas, or vapor depending on the filter type. Fit testing, required, can be done qualitatively or quantitatively. Half-mask fit test, yes. Full-face mask fit test, yes. Standards, complies with BSEN 12942. Important note: in the event of a fan failure, a degree of protection is still offered, but the wearer should exit to a safe area. Powered respirators with hoods/helmets, usage guidelines. Classification and protection factor. TH1, protection factor of 10. TH2, protection factor of 20. TH3, protection factor of 40. Work rate, suitable for medium work rates across all classes. Continuous wear time, recommended for more than 1 hour. Effectiveness, effective against solid and liquid particles, gases, or vapor depending on the filter type. Fit testing, not required. Standards, complies with BSEN 12941. Important note, if the fan stops or the flow rate falls, stop working immediately and leave the work area. Filter types and usage guidelines. White, P4 particles. Classes 1, 2, 3. Complies with EN 143. Brown, A for organic gases and vapors with boiling points above 65 degrees Celsius. Classes 1, 2, 3. Complies with EN 14387. Not for use against carbon monoxide. Gray, B for inorganic gases and vapors. Classes 1, 2, 3. Complies with EN 14387. Not for use against carbon monoxide. Yellow, E4SO2 and other acid gases and vapors. Classes 1, 2, 3. Complies with EN 14387. Not for use against carbon monoxide. Green, K4 ammonia and its organic derivatives. Classes 1, 2, 3. Complies with EN 14387. Not for use against carbon monoxide. Red, HGP3 for mercury. Complies with EN 14387. Maximum use time specified. White and blue, NOP3 for oxides of nitrogen. Complies with EN 14387. Single use only. Brown, AX for organic gases and vapors with boiling points below 65 degrees Celsius. Complies with EN 14387. No class number. Violet, SX4 substances specific as stated by the manufacturer. Complies with EN 14387. No class number. Breathing apparatus. 1. Fresh air hose BA. Description: provides unpressurized fresh air from an uncontaminated source via an air hose up to 20 meters long. Components: full face mask, wide bore hose, metal elbow, waist belt, wire reinforced air hose. Usage: suitable for work near fresh air sources. Breathing effort required, fan assisted masks or powered hoods can help. Fresh air hose, FAH, breathing apparatus, usage guidelines. Classification and protection factor. Assisted FAH with full face mask, protection factor of 40. Assisted/powered FAH with full face mask, protection factor of 40. Assisted/powered FAH with half face mask, protection factor of 20. Unassisted FAH with full face mask, protection factor of 40. Work rate. Unassisted, suitable for medium to heavy tasks. Assisted/powered, suitable for heavy tasks. Continuous wear time. Unassisted, recommended for less than 1 hour. Assisted/powered, recommended for more than 1 hour. Fit testing, required, except for hood, can be done qualitatively or quantitatively. Filter change schedule, not applicable. Standards, complies with BSEN 138 and BSEN 269. 2. Compressed airline BA. Description: supplies respirable air from a compressed air source, cylinder or compressor. Components: full or half facepiece respirators, hoods, coverall suits, protective visors, pressure-reducing valve, filters. Usage: suitable for static or mobile situations. Smaller, longer hoses, up to 80 meters, can be used. Positive pressure reduces fatigue and prevents contaminant ingress. Constant flow airline breathing apparatus, usage guidelines. Classification and protection factor. Class 1A, protection factor of 10. Class 2A, protection factor of 20. Class 3A, protection factor of 40. Work rate, suitable for medium to heavy tasks across all classes. Continuous wear time, recommended for more than 1 hour. Effectiveness, effective against solid or liquid particles, gas, or vapor. Fit testing, required, can be done qualitatively for half masks and quantitatively for full face masks. Standards, complies with BSEN 14594. Constant flow airline breathing apparatus, usage guidelines. Classification and protection factor. 1B, protection factor of 20. 2A, protection factor of 20. 3B, protection factor of 40. 4B, full face mask protection factor of 40. Work rate, suitable for medium to heavy tasks across all classes. Continuous wear time, no limit. Effectiveness, effective against solid or liquid particles, gas, or vapor. Fit testing, required, can be done qualitatively for half masks and quantitatively for full face masks. Standards, complies with BSEN 14594. Constant flow airline breathing apparatus with hoods/helmets, usage guidelines. Classification and protection factor. 1A, protection factor of 10. 2A, protection factor of 20. 3A, protection factor of 40. Work rate, suitable for medium to heavy tasks across all classes. Continuous wear time, time limited. Effectiveness, effective against solid or liquid particles, gas, or vapor. Standards, complies with BSEN 14594. Important note, ensure you have an adequate supply of clean compressed breathing air before use. Always look after your supply tube, as blocked tubes may lead to suffocation. Constant flow airline breathing apparatus with hoods/helmets, usage guidelines. Classification and protection factor. 1B, protection factor of 10. 2B, protection factor of 20. 3B, protection factor of 40. Work rate, suitable for medium to heavy tasks across all classes. Continuous wear time, recommended for more than 1 hour. Effectiveness, effective against solid or liquid particles, gas, or vapors. Fit testing, not required. Standards, complies with BSEN 14594. Important note, ensure you have an adequate supply of clean compressed breathing air before use. Always look after your supply hose, as blocked hoses may lead to suffocation. Constant flow airline breathing apparatus with full suit, usage guidelines. Classification and protection factor. 1A or 1B, protection factor of 10. 2A or 2B, protection factor of 20. Class 3, protection factor of 40. Class 4, protection factor of 200. Work rate, suitable for medium to heavy tasks across all classes. Continuous wear time, recommended for more than 1 hour. Intended use, effective against solid or liquid particles, gas, or vapor. Fit testing, not required. Standards, complies with BSEN 14594, Class A and B, BSEN 1073-1, Class 5, and BSEN 943-1, Class 1. Important note, always ensure you have an adequate supply of compressed breathing air before use. Regularly check your air supply tube during use, especially if you need to move around. 3. Self-contained breathing apparatus, SCBA. Description: provides air or oxygen from cylinders or containers carried in a harness. Components: compressed air cylinder, pressure gauge, reducing valve, orinasal facepiece, full facepiece with visor, demand valve. Usage: suitable for toxic, corrosive, dusty, and oxygen-deficient atmospheres. Types: Escape SCBA, short-term use, 10 minutes, compressed air cylinder at 200 bars, pressure gauge, reducing valve, demand valve. General SCBA, designed for 40 minutes of use, similar to Escape SCBA but with backpack-mounted cylinders, on-off control, pressure-reducing valve, warning whistle. Recirculating SCBA, long-duration use, up to 3 hours, closed-circuit system with oxygen cylinder or liquid oxygen container, scrubs CO2 from exhaled air, replenishes oxygen. Demand valve breathing apparatus, usage guidelines. Classification and protection factor. Positive pressure demand airline, full face mask, protection factor of 2000. Positive pressure self-contained demand, full face mask, protection factor of 2000. Work rate, suitable for heavy tasks across all classes. Continuous wear time, recommended for more than 1 hour. Fit testing, required, can be done qualitatively and quantitatively. Standards, complies with BSEN 14593, airline, and BSEN 137, self-contained. Important notes. Ensure the mask fits properly. Use equipment according to the manufacturer's instructions. Follow your employer's safe working procedures. Make sure you are medically fit to use this equipment, including your ability to drink and avoid dehydration. For oil shale dust and ash, the minimum respiratory mask protection is: type of device, particulate filter device, EN143. Filter class, P1, filters at least 80% of airborne particles. Fit testing. Fit testing ensures that respiratory protective equipment, RPE, fits the wearer properly to provide effective protection. This involves checking for a proper seal around the face. There are two main types of fit testing: qualitative fit testing, QLFT. Quantitative fit testing, QNFT. Qualitative fit testing, QLFT. QLFT is a pass/fail test based on the wearer's subjective assessment of any leakage through the face seal region. It uses a test agent that the wearer can taste or smell. Steps for QLFT. 1. Preparation. Ensure the wearer is clean-shaven where the respirator seals to the face. Select the appropriate test agent, e.g., bitter or sweet-tasting aerosol. Steps for using a respiratory mask. Place the respirator. Position the respirator over your mouth and nose. Pull the head harness over the crown of your head. Secure the straps. Hook the bottom straps together behind your neck. Tighten the top and bottom straps to create a secure fit. Do not over-tighten. Positive pressure face fit check. Place the palm of your hand over the exhalation valve cover and exhale gently. If air escapes between your face and the face seal, readjust the head harness straps. Negative pressure face fit check. With cartridges. Place palms of both hands over cartridges to restrict airflow. Inhale gently until the facepiece collapses slightly. Hold your breath for 10 seconds while keeping hands in place. The facepiece should collapse slightly and hold that position without leaking inward. With particulate filters, disc style. Place palms of both hands lightly over filters to restrict airflow. Inhale gently until the facepiece collapses slightly and hold that position without leaking inward. With setup for particulate filters. Squeeze filter covers with thumbs toward the center to restrict airflow. Inhale gently until the facepiece collapses slightly and hold that position without leaking inward. Steps for using a disposal respiratory mask. Stretch ear loops. Stretch the ear loops of each strap by pulling outward and holding for 10 seconds. Position the respirator. Cup the respirator in one hand, with fingertips positioned at the nosepiece and straps hanging below. Place the respirator on your face with the nosepiece on the bridge of your nose, positioning it over your mouth and chin. Adjust the straps. Pull the top strap resting it high over the crown of your head. Pull the bottom strap up over your head, positioning it around your neck and below your ears. Ensure the straps are not twisted. Mold the nose clip. Using both hands, mold the nose clip to the shape of your nose by pushing inward while moving your fingertips down both sides of the nosepiece. Avoid pinching or tenting the mask. Face fit check. Cup both hands over the front of the respirator without disturbing its position. Inhale sharply, a negative pressure should be felt inside the mask. If air leaks around the edges, reposition the straps or adjust the tension until no leakage occurs. If you cannot achieve a proper fit, do not enter the area requiring respiratory protection. Important notes. A proper fit ensures a tight seal between your face and the edge of the mask, reducing the risk of exposure to airborne particles. Do not use the mask if you have facial hair that interferes with the seal. Always perform a face fit check before entering a hazardous area. 3. Introduce the test agent. Place the test agent in a hood or enclosure around the wearer's head. Ask the wearer to perform a series of exercises, e.g., turning head side to side, talking, bending over, to simulate typical movements. 4. Assessment. If the wearer detects the taste or smell of the test agent, the fit test is failed. If the wearer does not detect the test agent, the fit test is passed. Quantitative fit testing, QNFT. QNFT uses a machine to measure the actual amount of leakage into the facepiece and provides a numerical result. Steps for QNFT. 1. Preparation. Ensure the wearer is clean-shaven where the respirator seals to the face. Calibrate the fit testing machine according to the manufacturer's instructions. 2. Fit the respirator. Have the wearer don the respirator according to the manufacturer's instructions. Perform a user seal check to ensure the respirator is properly positioned. 3. Connect the fit testing machine. Attach the respirator to the fit testing machine using a probe. The machine will measure the concentration of particles inside and outside the respirator. 4. Perform exercises. Ask the wearer to perform a series of exercises, e.g., turning head side to side, talking, bending over, to simulate typical movements. 5. Assessment. The machine will provide a numerical fit factor. A higher fit factor indicates a better seal. Compare the fit factor to the required threshold to determine if the fit test is passed or failed. Comfort and usability. Choose RPE that is comfortable for the wearer to ensure they will use it consistently and correctly. Maintenance. Regularly inspect and maintain reusable RPE to ensure it remains effective. This includes cleaning, replacing filters, and checking for damage. Inspection. Regularly inspect RPE for damage or wear. Replace any damaged components immediately. Storage. Store RPE in a clean, dry place away from contaminants. Proper storage extends the life of the equipment and ensures it is ready for use when needed. Emergency response and first aid. Emergency situations. In the workplace, certain situations can pose significant respiratory hazards. These include oxygen-deficient environments, areas where the oxygen level is below the safe threshold, 19.5% to 23.5%, making it difficult to breathe. Exposure to toxic gases and vapors, environments contaminated with harmful gases or vapors that can cause respiratory distress or poisoning. Confined space incidents, situations in enclosed or partially enclosed spaces where hazardous substances can accumulate, posing a risk to respiratory health. First aid for respiratory exposure. In the event of respiratory exposure, immediate and effective first aid is crucial. Follow these steps. Check. Call. Care. 1. Check. Protect yourself. Before entering the hazardous area, ensure you are wearing the required personal protective equipment, PPE, to protect yourself from exposure. Assess the situation. Check the victim's condition and the environment to ensure it is safe to approach. 2. Call. Emergency services. Call emergency services or alert others to get help immediately. Provide information. Inform them about the nature of the exposure and the victim's condition. 3. Care. Remove the victim from the hazardous area. Quickly and safely move the affected person to an area with clean, uncontaminated air. Provide fresh air and administer oxygen if needed. Once in a safe area, provide the victim with fresh air. If the victim is experiencing difficulty breathing, administer supplemental oxygen if available and you are trained to do so. Perform CPR if breathing has stopped. Check if the victim is breathing. If not, begin cardiopulmonary resuscitation, CPR, immediately. Continue CPR until the victim starts breathing or emergency medical services arrive. Seek immediate medical attention. Ensure the victim receives professional medical care as quickly as possible. If you have any questions, please contact the HSE department immediately for more clarification. Training evaluation. Please scan the QR code to reach the link, or you can find it in the video description. Exam. Please scan the QR code to reach the link, or you can find it in the video description. Thank you.